the next session, we will focus basically on study unit 6 and 7. So that will be the focus of the next two sessions. Okay, again, gonna take us through some previous assignment, previous exam papers. Then what I will also do later today is bombard you on the WhatsApp group again with some previous exam papers that was pre-COVID, so it was all paper-based exams. So I've got quite a few that I want to send you guys. So I will bombard you later today with about 6 or 7 of those papers, and most of them have some answers to it as well, that you can just practice some more. Okay, so today study unit 6 and 7, and in the week we will further continue with study unit 6 and 7. So study unit 6, 7 is around normal distributions. So study unit 5 was discrete. Now we're going into continuous distributions, and in study unit 6 we start off with a normal distribution. So you can see the first one is a bit more of a theory type question, and I think this has been a few times in your assignments as well. So let's, and I think I took this from your 2020 or 2021 assignment, so you can also see how things are replicated. So which of the following statements is incorrect with regard to normal probability distribution? Okay, so 100% a theoretical type of question, which again, it's not always difficult, but it takes up a bit of time because you need to go through the options, unless we're happy with an early option that might be wrong. So the z-score of a mean of a normal distribution is 1. Okay, so that already we can say is incorrect. Remember, the z it's normally anything from 0 up, 0 down. So z doesn't always need to be distributed as 1. The mean and the standard deviation, on the other hand, will be something different, but so that is definitely the wrong one. The smaller the value of a standard deviation, the narrow and steeper the curve. Okay, so that we know, the narrower the standard deviation, the steeper the curve. So you can just, it will be something like that. So just imagine that was both was normal distributions, and again the smallest, so that is correct. The mean of a normal distribution can be any numerical value, negative, 0, or positive. That is also correct. The area to the right of the mean is 0.5, correct. And the area left, okay, so left and right, both of them 0.5, so that is correct. 95.4% of the values of a normal random variable are within plus minus 2 standard deviations of a mean. That is also correct, and that one is nearly the one we will see in when we look at study unit 8 again a bit later. So that will normally be the one where we will get 95%, that will be equal to 1.96. And the reason why is also nearly, if you look at that's 2 standard deviations. Okay, so those are all correct. The Z score of a mean of a normal probability distributed is the incorrect one. Okay, so in the exam, if you get it like this, A is the wrong one. Continue, pick it, continue. Remember, again, how this exam will work is it's a linear exam, so and I must actually just find out, but if that has changed, but I don't think so, is that you can't go back. So I will just make 100% sure again if that is the way it is structured for this one as well. So I will let you know in the week. Um, okay, so let's go to the next one, and I probably need to open up my Z table as well. So consider the standard normal distribution of Z. Which one of the following probabilities is incorrect? Okay, so let's first see again some of it. It's a bit of theory. Some of it we need to go to the table. So let's look at that first one. I'm not going to go to the table yet. I want to just see. So Z bigger or equal to, let's say that is minus 2.8. So we're looking for the bigger, that is the area. Or we say it is 1 minus Z bigger or equal to 2.8. Okay, so 1 minus that small area will give us this big area, which is equal to that big area because we're looking at the same value or the same number. So those two are equal. Okay, so we don't, for this one, didn't need to go to the table. We will later on just confirm it with other numbers that we definitely would need to go to the table. So let's look at option B. So Z smaller or equal to 2.1. So if that is 2 or minus 2.1, that small area is that equal to bigger or equal to 2.1, and we know that is correct. So that is also correct. Then let's go to C. Z smaller than 0, but bigger than minus 2.8. Okay, so we're looking for that area. Okay, so we will need to go and look at the table. So first we can say, well, this will be smaller than 0.5. So this area will be smaller than 0.5, which it is at the moment. So let me open my set table. Let's quickly see. Okay, and let's go to find that. So we can do two things. We can find that small area and say 0.5 minus that small area. So let's do that first. So minus 2.8 is 0, it's different color. Let's just now see if we can get there. Has a 0,0026, 0,0026. So if we work that out, 0.5 minus 0.0026, we get 0,4974, which is correct. What we can also do is we can take the plus, so let's do the 2.8. Zero comma 9974. But then remember we need to subtract 0.5 from it. So 0.9974 minus 0.5. Let's just do that again. 0.9974 minus 0.5 also give us the 0,4974. Okay, so again, just showing with the negative Z table and the positive Z table, you can both work out to get to the same answer. You have access to both. It's not like in the olden days where they only gave you one and you needed to work with it. You have access to it. I will resend that study or the 101 booklet in any case that you have that as well again, if you are looking for that. Okay, so then let's look at between minus 2.8 and there is 0. The other one is 2.1. Okay, so again, we can do this on two methods. We can say we know what that number is already. It is 0,0026. So we can get the 2.1 number. So that minus 2.1. Let's first get that. It is 0,0179. So if I want to get this area, I just say 1 minus those two. So 1 minus 0.0026 minus 0.0179. That will give me 0,9795, which is that answer. What you can also do is to say, well, get the 2.1 but now it is a longer process. Let's get for positive 2.1, 0.9821. So we could have set 0.9821 minus 0.5. That would have given you this area, which is 0.9821 minus 0.5 is 0.4821. And if you add that to this one that we have calculated, you will also get, or you're supposed to get, the same answer. So let's check 4974, which will also give you that answer. Okay, so you could have broken it up into two pieces to work those two out separately, because we had that one at the top. You could have just worked that one out, and we add the two, or we can say, well, we want that area, let's subtract the two smaller areas. Again, up to you what is the easiest for you to work with. And then we actually now have done that second part where we wanted to work out what's the gap or what's the probability between 0 and positive 2.1. It should be 0.4821 and not 4221. So that one is the incorrect one. Okay, so again, showing you guys a few options, how to work it out, but use what you feel most comfortable with. I think that is the most important one. Is don't, if you find with using the negative table, use that. If you're okay with a positive table and know how to change it, do that. If you like using both, then also do that. So I think especially with these ones, just get a method that you're comfortable with, because you will get, again, one or two questions around this will be in your exam. Okay, so let's continue. Let's see what is in this one. Given that the Z is standard normal distribution, what is the value of Z such that the area to the right of Z is that? Choose a correct answer from a list of options below. Okay, so let's and they say to the right. So then to the right is this area. So if this area is 0.2061, what is that Z value? Okay, so first we can see that Z value is going to be positive. Okay, so that already is one thing. So again, in the exam, if I draw that, I will say, okay, must be positive. It's not A, it's not D. Okay, so then at least if I need to guess, it is between three numbers and not five numbers. Then I will say, okay, I'm comfortable using the negative table. So if I get that value in the negative z, then I know I can just change it to positive because of a symmetry. So I'm going to look for 0,2061 in the negative z table. Okay, 0,2061. Okay, 20. There it is. Okay, so we can see 0,82. So minus 0,82. But remember, it is on the positive side. So it is positive 0,82. Positive 0,82. Answer is B. Okay, what they might do also is, again, different papers. There might be 2 or 3 of these floating around. So for some of you, they might say, such that the area to the left of Z is that. So again, it might be just slightly different questions, because we know there is always going to be 2 or 3 different question papers floating around in the exam. So that might be also how they would ask it. They will now not go totally off on a different type of question for the 3 different papers. It will be something like this, where the one will be that, the other one will be this side, and then they will just make sure that that is randomly shuffled, so that you don't will not pick the same answer. Okay. So let's then go into one where we need to start working with the formula as well. So first, we will need to get the Z, and then from the Z, if it is probability, we need to get probability. If it is something different, we will need to make sure what we need to get. They can start bringing in, remember again, with the overlap between chapter 6 and 7, they might start bringing in the question about the standard error. So we might get a question around the standard error in the next 1 or 2 slides, where we then start going into the sample sizing, and then there will be a standard error, but we'll see. So consider normal random variable with a mean of 3,000 and a standard deviation of 1,800. That is still standard. Random variable that is at most. Okay, so probability of Z at most, so it can't be more. So it will be smaller or equal to 3,800 minus 3,000. So if we going to draw it, we're going to have a value here, and we will need to see at most everything below it. Okay, so let's first see if it's positive. Yes, it's going to be positive because it's 800 divided by 1800. So it is going to be a positive number. So that means we are right, and it will then be bigger than 0.5 a probability. Okay, so just by seeing that, and let's hope I'm working it out correctly, but that Z is 0.44. It means that we are on the positive side. That means my probability will be bigger than 0.5. Okay, so there's a probability bigger than 0.5. Not. Okay, so in the exam, you have basically two options to pick. Okay, so it does make it a bit simpler. So if you are pressured for time, it does make it a bit simpler. So this one, we can go to the positive Z table because it speaks to what I'm looking for. Everything under that probability of Z equal to 0.44. Okay, so let's go to the positive one. Z equal to 0.44. Okay, you can see I have used this at some point. 0.44, 0.67. So Z equal to 0.44, and the probability is 0.67, which is option A. I just want to quickly check the 0.8665. 8665, so 1.1. How would we have gotten to that 1.1? Okay, so probably if we said that goes up there, yeah, don't know. Okay. Okay, so that is just using the Z formula to get to a Z number. From the Z number, we go to the Z table to get the probability. So on this one again, it could have been that they have this and they change these wordings. Okay, because now they can say at most when we know it is up until there, or they could have said less than, and then we know we need to shift our, so that again is how they will be able to make it different for the different papers. Okay, so let's go into the next one. Again, I will share this representation afterwards, that you have it with a recording. Okay. Upon conducting further research prior to the organizing scholar transport, the education department found that learners' travel time from home to school at one of the remote rural schools is normally distributed with a mean of 114 minutes and a standard deviation of 72. What is the probability that learners' travel time from home to school? Okay, so now we get to it's less than 100 minutes. Okay, so divided by the 72. That is how we going to work out the Z, but then that Z will be less than, is less than. So wherever we end up, let's first look at the Z so that we can see where we land up. So that is 100 minus 114, so that's going to be negative. Okay, so this is a weird number, so let's hope it is Correct. I get Z is smaller than 0.19 or minus 0.19. Let's hope that is correct. Okay, so we're looking for less than. So we're looking for the smaller. So then again, I know that that will be smaller than 0.5. So if I look at answers, okay, that can go, that's out, that's out, that can be, that's out. So again, just by doing that component first without needing to go to the table yet, we basically have eliminated three options. So only two that we need to select. If we are guessing, then at least it's only two that we need to guess from. Okay, so let's go to negative table 0.9 and hope that is 0.1. It's just that's 0.1. Okay, but first negative table. Sorry. 0.19. 0.4247. That is 0.4247. Okay, there is actually, so that was worked out correctly. Okay, 0.4247, and that again we got straight from the negative Z table, so we didn't need to nearly do anything else. We got it from there. Okay, so let's move on and see what is the next one. Okay, so now we get into a few of those funny ones where we need to do other things. So consider again the findings, blah 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 blah. Mean 114 again, standard deviation of 72. An education consultant has recommended no more than a certain minutes of learners' travel time to school. Okay, if a department would like to ensure that 15.15% of learners adhere to a recommendation, what is the recommended travel time? Okay, so what they basically is saying to us, you've got a Z of 114, so this is the formula. We need to work out what is that X value, but they tell us that Z no more than 15.15%. So if we look at a Z table, I would have said, okay, in here we need to look for 0.1515. Then we will get a Z value. That Z value is going to be equal to X minus 114 over 72, so that we can work out what the X is. Okay, so negative Z, 0.1515, we need to look for 1515. Okay, so that is minus 1.03. 1.03. So minus 1.03. Just wanted to write it down first. Okay, so then that is going to be our formula is Z needs to be, we know the Z now, so from there we can go and say, okay, minus 1.03 is equal to x minus 114 divided by 72. So first thing, get rid of a 72, so minus 1.03 times 72 is equal to minus 74.16. That is equal to x minus 114. And then I take the 114 over, which then becomes plus 114. So I get x is equal to 39.84, which is then approximately 40 minutes. Okay, so that is how we would work out this one. So it is different to the other questions because we basically are getting the probability. So they give us that probability, the 1515. We need to get from that go to the table to get the Z. So that in a sense has all been given, not straightforward given that they told you Z is equal to minus 1.03, but in a sense it has been given and we need to work out the X. So a bit different to what we normally would do is work out the Z, go to the table, get a probability, and this time we basically work it the other way around. Okay, so I'm just also flagging this. I think this is one that they might also ask something like this in the exam, linked to a question like this. So these two are very closely linked. Where again the same principle we will nearly follow for this one. So let's just check the emotional EQ score at high school learners is normally distributed with a mean of 80, standard deviation of 20. If there were 2969 learners with scores higher than 95, how many students took the EQ test? Okay, so now we have the X. Let's get the Z. So Z is 95 minus 80 is 15 divided by 20. So Z is equal to 0.75. So let's see what that means for us. So that is 0. So is Z 0.75. So that area, they tell us we have 2969 students. We need to then check on the table what is that proportion or that probability. So I would go to the negative table get 0.75 and see what the probability is. 0.75, let's just check. Okay, 0.75, so 0.2266. So this probability is 0.2266. So basically, how do I work out how many students there are? If this area is, let's say, 23% of a class, then, and that 23% is 2969, we need to get 100% of a class and not just 23%. So 2969 divided by 0.2266 will give us what the total class is. So this component that we have here is 2,996 students, or 69 students, and that is equal to 0.2266. Okay, so I want to know how many students are there in total. So for that, I need to say, okay, well, if this is 2969, if we take another 0.02266, there will be another 2969, but then, yes, there's another component, 2969, and then there's another component, 2969, and then another small component. Okay, so the easiest is to say 2969 divided by 0.2266, and that total will give me 13,102. Okay, which is option C. Okay, so you could see that we could get the answer like that. Okay, so if I look at the 0.2266, so that's about 4 of them. So you could roughly say 2969 times 4 will give you 11,876. So 11,876, you know it's not going to be that one, or that one. And then you need just a bit more to cover that last piece. So you can also, by that process, get to a 13,102. Okay. So again, a bit different, because here we basically are setting things as equal, and you need to get the whole 100% and not just for 22.66%. Okay. Again, a different question, and now in the exam they will not ask both of these. So it's not that they're going to ask you to work out the one where you needed to solve X and this one. If I ask you, one of these might be, but they're definitely not gonna ask you to do both. That is just not how they will do it. Okay. Okay, so let's look at. So this is still all basically study unit 6. If I look at this, we haven't started with a sample. Here also still everything study unit 6 related. See, now we only start. So let me quickly just check. Let me quickly, and you can see there's there's still a lot of us that we are gonna do. So let me just see if there's not anything more specific. Just to study unit 6 that we, okay, so that one we can actually bring in here as well. That one we can also bring in, so that let's just do that when we cater for a few of the study unit 6 ones. Okay, so let me quickly just, when we can, nearly end off with these 3. When we have covered again 10 questions for study unit 6. Okay, so let's see. It is a bit blurry. It was, I think, last year or the year before, it was one of those assignments. So let's quickly check. That 1610 marks for a first assessment recorded an average of 62. Okay, so here again we're going to nearly do the same as we did with the previous one. And the standard deviation of 21. A total of 1,074 students submitted the first assessment. Assume that the marks are normally distributed. Approximately how many students have passed the first assessment with a distinction of 75 or more? Okay, so now we want to work out what is the set bigger than that. So then this is slightly different. So we're gonna, let's just see why this again. Okay, cool. Slightly different. So now we know that the total students is this 1047. So what we're gonna work out is we need to get this area, that, and then we will need to say, okay, that area times for 1,47 will give us how many students are in this component. So now remember the previous one, we got that small area and we wanted to work out all the students. Now we've got all the students and we just want to work out this area. So again, I think it's a nice one that we have all of these nearly stacked together. By fluke, it worked out a bit like that. So let's just see. 75 minus 62 is 13. 13 divided by 21. Z bigger than 0,619. So let's make it 0,62. Again, I'm going to go to a negative table so that I can just get that. 62, 0,6, 0,62. So 0,2676. So that is 0,2676. So if my whole area is 1047, I want to find out what is this area. So the 0.2676 times that should give that to me. And they say it's approximately, if I work that out, 280. Okay, so again, that should not be. Okay, the person got only 1 out of 2 marks, so that was not 100% correct. Okay, so so that is how it will be in the exam as well. So what this person worked out was actually that other half, or that other component. So if you check 1047 minus 280 would give you the 767. So what this person worked out was the score of 75 or less. So that was where that one came. So the 6 or the 767 was the rest. So that one is wrong. But you can see if you have done this in the exam, you would have gotten 1 out of 2, or if the exam mark will be 4, it will be 2 out of 4. Because what you did was correct. You just looked at the other component and not the 75 plus. You looked at 75 minus. So you actually have worked out all the other things correctly. But in the end, you just made the wrong decision. So you will still get some of the points. Okay, so this was actually quite cool that we have one where we needed to look to get the total number of students, and then we had the one where we got the total number of students and we needed to then work it down towards a certain component of the students. Okay, then they also sometimes do something like this, where somewhere in the study guide they would have mentioned what this referencing is. So this is just saying consider standard normal distribution where Z is normally distributed, mean of 0, standard deviation of 1. What is the probability that Z uh, that Z of 0,06. So what is that probability? Okay, so again, I will look at the other way around. So let's just see. So it's actually smaller. So I would have made a mistake now. Okay, so that's actually smaller. So it is a bit bigger than 0,5. So we can see there's the 0,5 mark. It's a bit bigger than 0,5. So that can be an option. That can't be an option. That can be an option. Can't. Can. Okay, so then we want to get that area. So this is spot on the area if we look at the positive Z table. If we look at the positive Z table of 0,06, and there we can see we're looking for that area 0,06 on the dot 0,06, or sorry, let's just make now 100% sure, 0,06. Okay, luckily there wasn't one for 0.6. 0.06, let's delete all of them just. Okay, 0.0, 0.06. 0.5239, 0.5239. Luckily, and it might happen in the exam that might have been one of the answers, because that's where I went first, because I had the 0.6 in my head. Luckily, 0.7257 was not one of the options, but I nearly went there first because I missed the 1-0. So just be careful also in the exam. Nearly learn out of some of the mistakes as I'm going through this. Um, okay, so that one, so how we normally reference that is that Z is normal distributed with your mean and your variance. And one of the things that we know about the standard normal distribution, mean of 0 and variance of 1. Okay, so that's just so what they might do, and I think that's also important, is they could have given you this. So now they've given you the Z and everything, but they can also give you Z normally distributed with the mean of, let's do it here, that you can see. So normally distributed with a mean of 62, and then that would have been whatever that is. Okay, so they could have done it that way, that you know that, okay, this is the mean and that is the standard deviation slash variance that we're working with. Okay, so, and I think that's why it's important that we just know the notation, so that they don't need to again spell it out. The mean is this, the standard deviation is this. They can just give you that notation. I will check for something like that in one of our other. I know I have something like that somewhere where we looked at that notation. So I will get a question for you guys where we just make sure that we get the notation right and that you have it. So if they give that to us in in a the exam, we know what to do. Okay, so let's look at the last one for today, and again linking very close to some of the previous ones we did. So let's read and see what, again, EQ score. So you can see that was one of those, again, normally distributed with a mean of 80. So we've got the mean of 80, standard deviation of 20. Okay, here we're actually going into study unit 7, because we suddenly getting a sample. Okay, random sample of 36, so that is fine. Let's put that in here as well. It is further known that the probability that the mean EQ score is more than X is, okay, so more than X Okay, so let's just read this. It is further known that the probability that the mean EQ score is more than X is 0,8849. Determine the value of X such that the probability of X equal to 0,8849. Okay, so 8849. So I would have said, phew, that is my 0,8849. Let's just make 100% sure about this. No, it is the other way around, because that is less than. Okay, more, not less, more. Sure, okay. This is quite a tricky one. So I first looked at it and I thought it should be there, but that area can't be 0,8849. Okay, so then it must be lying somewhere here where this area then will be equal to 0,8849. Okay, so again, important why I like to draw this from the beginning is I wanted now to say I need to get that area, but that's not, I need to get bigger than. And this area, when I have drawn it, I could now see, okay, this area, there's no ways that can be 0,8849 because this whole area is 1, so this is a small area. So what I'm actually looking for is that Z will be on this side and this whole area will be equal to 0,8849. So this small area then is 1 minus 0,8849. So that small area is 0,1151. Okay, so again, when you draw it, you can, that's the only way where I know, because in my mind, I'm seeing that as positive. That's why I went to the right-hand side immediately. But then I have written it down, so yeah, I can see, but hang on, if that is my probability, that probability can't fit into this small area. It is that bigger area. So that is actually the small area Z. We will need to find a Z where the probability is 0,1151. Okay, 0, so that's going to be a negative 1151. 1151. Okay, there is actually 1151 minus 1.2. So that is minus 1.2. So now I can say minus 1.2 is equal to x minus 80 over, and let's work that out. 20 divided by 6 is 3.333. So 3.333 times 1.2. Okay, so this side minus 4. That feels weird, but okay. And if I then take that 80 over minus 4 plus 80, I get that x is equal to 76, which is option D. Okay, so this is a bit different from, again, the previous ones. This made me think twice, because originally I went and said, I looked at that and my original thought was, okay, it's going to be somewhere here, but then remember more than, so I can't in that small area now suddenly have 0.8849. It does not make sense. If that whole area is equal to 1, that small area can't be. Okay, so instead of having it on this side, I moved it to the negative side, and then it is possible to have this whole area to be equal to 0.8849. So that means that we can get that smaller area, which is 0.1151. Then 0.1151 is on the Z table, where it is Z is equal to minus 2. So Z equal to minus 1.2 is equal to what we have written out. And by that way, then we can work out your X value. Okay, so it is, in a sense, like we did in this one, or where was it that we needed to work out the X, so this one. But the big difference was in the wording, where they said that it must be more than, so important. The more than then tells us that my Z value is going to be negative. It lies on the left hand side. Then again, if my Z is negative, that means that X, and how we can look at it, that top part must be negative. So the only way that can happen is that my X is smaller than my mean. Okay, so again, that would have been something that I would have looked at to say, okay, well, if X must be smaller than 80, so that could have been, and all three of those could have been answers. Yeah, so that is nearly the beginning and the most difficult one that we will see in study unit 7. So the next session, we will just continue on and look at examples of study unit 7. Then we will move into study unit 8 again, but the next session, we will cover study unit 7 in full. Okay, so that is it for today, everyone. So we've